Right now, we continue with example 6. This is from previous semester papers. Okay. Differentiate y equals to e to the power of 2x ln 3x plus inverse tangent 3y. Okay. So to differentiate this function, we can differentiate one by one because in between is plus. Okay. We can let a equals to e to the power of 2x ln 3x and b equals to inverse tangent 3y. Okay, and then we differentiate a and b. Okay, to differentiate a, we can use product rule because this is multiplication functions. Okay, and then when we differentiate using product rule, we need to identify u and v. And then we need to differentiate u and v, so we get u prime and v prime, right? Right, when we differentiate e to the power of 2x, okay, first we just copy the whole function. So we get e to the power of 2x, okay? We refer from the basic formula of exponential function. When we differentiate e to the power of x, we will get back e to the power of x. So when we differentiate e to the power of 2x, we will get back e to the power of 2x. But after that, we need to differentiate exponent. Okay, so we differentiate 2x here, we get 2 here. Okay. When we differentiate 2x, we get 2. So we put in front here. Okay. And then when we differentiate ln, okay, so we can refer basic formula for ln. Okay, derivative of ln single x equals to 1 over x. We put x here in denominator. So when we differentiate ln 3x, we will have 1, we copy from here, and then over, and then we put 3x in denominator here. Okay. But after that, we need to differentiate 3x. Then we get 3 here, right? Okay, after that, we simplify 3. Okay, so we get 1 over x, right? And then using product rule formula, when we differentiate a, the symbol become a prime. And then when we use product rule, the formula is vu prime plus uv prime. Okay. And then we have a prime equals to, we just cross multiply here. So we get 2e to the power of 2x ln 3x. And then plus, we multiply e to x and 1 over x here. So we get e to the power of 2x over x. So this is our a prime, okay, when we differentiate this. Okay. Right now we look at b. Okay. b equals to inverse tangent 3y. Okay. Alright. To differentiate inverse tangent 3y, okay, we need to use inverse trigonometric rule. Okay. When we differentiate b, the symbol is b prime. And then when we differentiate inverse tangent 3y, okay, we can refer basic formula for derivative of inverse tangent, which is inverse tangent single x. When we differentiate inverse tangent single x, the answer equals to 1 over 1 plus x squared. Right? Now we have inverse tangent 3y. So when we differentiate, we get 1 over, we just copy from here. And then 1 plus, we follow from here. And then x now we replace by 3y. And then we have squared here. Okay? But after that, we need to differentiate 3y. Okay, so when we differentiate 3y, we get 3 dy over dx. Okay, every time when we have variable y, and when we differentiate with respect to x, we should have dy over dx, right? But for a here, there is no variable y, so that's why there is no dy over dx here, right? And then from b prime here, we can simplify, so we get b prime equals to 3 over 1 plus 3y bracket squared, we simplify, so we get 9y squared and then dy over dx. Right? Right, from the given question, we have y equals to e to the power of 2x ln 3x plus inverse tangent 3y. Okay, and then we differentiate implicitly with respect to x. Okay, because we have variable y here and here. Okay, and then we just differentiate one by one. Okay, when we differentiate y, the answer equals to dy over dx. We differentiate y with respect to x. Right? And then from the previous slide, when we differentiate e to the power of 2x ln 3x, we get this answer. Okay, we have plus here because we use product rule. Okay, because this is two multiplication function. So that's why we need to differentiate using product rule. Okay, alright, and then we differentiate inverse tangent 3y from the previous slide. We get 3 over 1 plus 9y squared dy over dx. Okay. And after that, we need to separating the term containing dy over dx and not containing dy over dx because we want to find dy over dx. Okay. So from here, okay, after we move to left hand side, we get this. Okay. Right. From positive 3 over 1 plus 9y squared dy over dx, this is the term containing dy over dx. We move to left hand side, okay? Because now we want the term containing dy over dx on the left hand side, okay? Right, so we get minus 3 over 1 plus 9y squared dy over dx, okay? And then right hand side equals to 2e to the power of 2x ln 3x plus e to the power of 2x over x. Okay, and from here, we can factorize dy over dx. Okay, we have dy over dx here on the left side. So we factorize, so we get dy over dx in bracket 1 minus 3 over 1 plus 9y squared. Okay, and then right hand side equals to 2e to the power of 2x ln 3x plus e to the power of 2x over x. Okay. And after that, we can write dy over dx as a subject. So we move this bracket to right hand side. So we get dy over dx equals to 2e to the power of 2x ln 3x plus e to the power of 2x over x, and then over. From here, when we move to right hand side, so we get over here, okay? Over 1 minus 3 over 1 plus 9y squared. Now, from left hand side here, we get dy over dx symbol, okay? And right hand side, no more dy over dx. So this is the final answer, okay? This is our dy over dx, right? Or from here, okay, we can standardize the denominator here, okay? Because this answer, we have fraction in fraction, okay? So looks like quite messy, okay? So let's say from here, we want to standardize the denominator first, okay? So from here, we standardize the denominator, and from here, we standardize the denominator, okay? And then we simplify 1 minus 3 equals to minus 2 here, okay? And then when we move this fraction to right hand side, okay, the denominator become numerator, okay, and the numerator become denominator, okay. So when we write dy over dx as a subject, so we have 1 plus 9y squared times 2x e to the power of 2x ln 3x plus e to the power of 2x over x times 9y squared minus 2. Okay, this is the final answer. So you can write your final answer as dy over dx equals to this one or this one. Alright? Coming up next, integration of inverse trigonometric functions. Okay. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.